Hi everyone. Today we are going to be focusing on how we can find solutions to systems of equations by graphing. So after we finished our bell work, you're going to be moving to different stations. One of the stations is this video where you're going to be taking some notes. After you take the notes that are going to explain some of the vocabulary we're going to be using in class and that you should be using while you're working on this, you will then, one of the stations will be to meet with me to see if you can actually work through and start working on the practice that goes along with this. So first of all, your worksheet, the notes that you have should look like this. And I'm going to scroll to the next page and kind of go over our vocabulary. So graphing systems of equations, some vocabulary you're going to hear me say is a system. So what is a system of linear equations? Linear means lines. So, and we have equations. So we know how to take an equation, we know how to make a line, but now we're dealing with a system. And a system is basically more than one line. So it consists of two or more linear equations in the same variables. So both equations will have x and y in them, so they'll be on the exact same plane. So on a graph, you would see two lines together or more. A solution of a system of linear equations in two variables is an ordered pair that satisfies each equation of the system, which means this ordered pair is a solution to each line that is on your graph. And how you can recognize that is by looking for the POI, which is known as your point of intersection. So if I graphed one line and it has this positive slope that goes this way in pink, and I have another line that has this negative slope in purple, their solution would be this point right here, this point of intersection, which is the solution. It is the ordered pair that they would have in common. So if you think of the detention buyout that we did, there were many places where the three lines intersected one another. That line, then you had to make a decision, because at that point both buyout plans were the exact same dollar amount. So that would have been a common solution that they both had, and then other decisions and factors would have to be made as to which plan would be the better plan to choose. So whenever you see this point that is intersecting the two, that is your solution to an intersection. However, just like with every other graph we've done, there's a possibility where you have no solutions. No solution means that the lines don't have any common point of intersection. This would happen when you have, you can see here in the picture, parallel lines. They would never intersect, therefore they have no common solutions at all, so no solution would be your answer. Please make sure that you are doing all of the little sketches on the side and underlining some of these important phrases so they stand out and easier to find on your notes. The next part is what happens if you graph an equation and the second equation you graph is identical. That we talked about this before and how the lines would lay right on top of each other as you see the pink line and the green line on top of that. This would be the exact same line, so that would have infinitely many POIs, point of intersections. Every single point along this line is something they have in common, which would be a solution. So you could have one point solution when the lines crisscross. You can have no solution when the lines are parallel, and you have infinitely many solutions when the lines are exactly the same. All right, the next part of your notes is the bottom part, which is looking at those graphs and just looking at some commonalities. Sometimes you don't have to graph at all. If you can actually look at slopes and the intercepts, you can make these decisions as to knowing how many solutions they're going to have before you even start. So this is the bottom of your notes. So let's go ahead. I'm going to click to the next page and start writing things in. So number of solutions of a system. If they have different slopes, so if you have different slopes, your lines are going to eventually cross. So if the lines are going to cross, like in this one, what's that thing? Don't know. You will have a point of intersection, which is right here at point 1 and up 2. So 1, 2 would be the solution. The lines intersect. There's only one solution of 1, 2. All right, so different slopes automatically would have only one point of intersection, which would be one solution, and you should be able to give me an ordered pair. So if I ask for the solution, you would tell me the solution of this system is 1, 2. Okay, the next one, what happens when they have the same slope but different y-intercept? y-intercepts. When you see this, you would notice that you have your parallel lines, different y-intercepts, but the slope is up 1 over 1, up 1 over 1. These lines will never ever cross. They are parallel, therefore there are no solutions, no intersections, no common answers. The next thing to look for in your equations is if they have the same slope and the same y-intercept. So if they have both of those are the same and you went to graph them, they would lay right on top of each other. So we would say the lines are the same, so there are infinitely many solutions. So those are the things that you need to know to do the first part of your assignment, is to start identifying how many solutions, and then if there is one, what would it be? So go ahead and go to your worksheet. Oh, no worksheet, sorry. We're going to do a couple practice problems first that you will find just to see if you can do this. It does say that they want us to graph this. Technically, we shouldn't have to graph it. We might have to do some rewriting, but we should be able to look at this and using the clues from our notes to determine what kind, if this is going to be an intersecting line, coinciding, which means the same lines, coinciding is the same as same, or parallel lines. So go ahead and look at this and go ahead and check which one you think. It's also great practice to try and graph it. So when you're done, go ahead and graph it, see what the line looks like, and then pause the video. And when you think you have an answer, take a guess first as to what you think based on your notes, and then go ahead and graph it to prove it. If there's a solution, tell me what it is. Solution would be a point. It'd be no solution or infinitely many solutions. So pause right now and try this problem on your own. All right, welcome back. Let's go ahead and look to see how you did. So first of all, you would see that the first slope is -1/3, the second slope is 2. They don't have the same slopes. That means that they would be intersecting lines based on our notes. Now, where they intersect at, that's when you would have to graph this in order to find your solution. So you can see in red here, I started again at -2 as my y-intercept, and I went down 1 over 3, down 1 over 3 for my slope. And my other equation, I started at 5, and I went up 2 over 1, up 2 over 1. Where those two lines intersect is that point right there, and that would actually be -3, -1 would be your solution. All right, let's go ahead and look at this next problem. Why don't you go ahead and pause the video, go ahead and check which one you think this is, intersecting the same lines or parallel lines, and feel free to graph it to prove your answer. Okay, welcome back. And let's take a look here and see how you did. So first of all, you would notice that the slope is 1/4, the slope is 1/4, same slopes, different y-intercepts. When you graph them, they look like this. They are parallel, so parallel lines is what they are, same slopes, parallel lines, different y-intercepts, no solution at all. And you can prove it here by seeing that they don't intersect. All right, the last problem you're going to try is this one right here. The first thing you're going to know, this is a dandy, is that none of these are written in slope-intercept form. So the first thing you have to do is rewrite. Get the y on one side and the x and the numbers on the other. You can do that using boxes or just by doing the do and undo method in class. Go back in your notes if you need to look. So first of all, rewrite the equations. Find your slope and y-intercept. Check which one you think it's going to be based on our notes, and then graph it and come up with an answer. Pause the video now, give this one a try, and then we will hit play to see how you did. All right, so here's the problem. And it's a lot of work here. So what I did first is this equation here, x minus 2y equals 2. So y is on one side, x's and numbers on the other. If you cross the line, you flip the sign. In order to get y by itself, I'm going to divide everything by -2, and I end up with y equals 1/2 x minus 1. So there's my first equation. My second equation is over here. So I want to get y's on one side, x's and numbers on the other. So this -2x turns to a +2x. I got to get y by itself, divide everything by 4, and I get y equals 1/2 x minus 1. When I look at these, they have the same slope. They have the same intercept. Therefore, according to our rules, these are intersecting lines. There should be no, or that's no solution. I got this one wrong. Nice job. That is not correct. So I'm going to erase that. And let's see, I don't even know if I can get, let's type that in. Okay, so it is actually infinitely many solutions. All right, so if you can tell, the lines are on top of each other and the solutions go on and on. Sorry about that, kind of got carried away with my answers. All right, and there's the proof. You see the lines on top of each other. So that one is like the most work you'd have to do. A lot of this is review, but now we're just dealing with, instead of doing one line, we're doing two. All right, so at this point, you can pause the video and you can either get started on the practice worksheet or if you are ready to, or shortly ready to rotate, you can hang on and rotate with the class. All right, see you later.